to stand up, and I will let you guys choose your seats based off of your, what did we say? We're going to let you choose seats based off of your what? Yeah, your grade. So I have you guys all numbered. That's what I'm doing. The quarter that just ended, the trimester that just ended. Yes, sir. Okay, so here we go. The imaginary number unit. Well, remember we just said that the imaginary number unit, I'm going to write this up here nice and big so you guys remember, that came from the square root of a negative number. So we took out the square root of -1. We're just going to take that out. And remember we call that I. It stands for the imaginary unit. We're going to just call it little cursive I. So 3 things can happen when you're solving quadratics by graphing, okay? You could have something like this where you just touch the quadratic, just touches the x-axis one time, right? And that means, I'm trying to make a nice big blob. And that just means that you have one solution. You guys know that, right? Okay. You could also have something where your graph goes through the x-axis 2 times. Jaden, do you see yours? First page. This is your filled out note section. This is your homework section. I did it separately. Does that make sense? We have 2 packets. Notes, homework. Okay, because instead of me like making copies and us getting it out of, do you see where they are, Thomas? So I did a filled out copy of notes, and then this is just your homework. Okay. All right. So let's talk about it. So what happens when it enters? So we said that this is 2 solutions, or maybe we didn't, but I know that you guys know this is 2 solutions. But sometimes the parabola is above the x-axis, or it could also be what? Below the x-axis, yeah. This means that it's not no solution. This just means that it has no real, right? So I'm going to use that abbreviation for real numbers. This has no real solutions. No real solutions. What it has this has 2 complex solutions. It has 2 complex solutions. And a complex number is just a number that has I in it. 2 complex solutions with I. Okay. So what's the big idea with this? Well, the big idea is this whole square root of -1. So when we have the square root of -1, we pull it out and we replace it with an I. So remember that we can't take the square root of a number, right? So I'm just going to write, there is no number that when squared equals a negative. Maybe I should just write the word negative instead of the symbol. Right? There's no number that when you square it equals a negative. So we learned early on that you can't take the square root of a negative number. But all of the time we end up with negatives in our radicals because it's still graphable, right? So we have to figure out what kind of a solution that is. So we do this by rewriting it as a product, right? And remember whenever we break up a radical and we write it as a product, we want to write it as something times a perfect square, right? Well, now we want to write it as the square root of -1 times a perfect square. And then if we still need to break it down more, we can. So when I look at the square root of -9, I'm going to rewrite this as a product of the square. Oh, it's way too thick. Sorry. I'm going to write it as the product of the square root of -1 times the square root of 9. Well, what is the square root of -1? Well, that's the big idea. It's I. It's that little cursive lowercase I. And what is the square root of 9? It's 3. So we rewrite this as 3I. The real portion comes first. The imaginary portion comes second. Sir. Okay, I just explained it. You can't take the square root of a negative number, but you have to be able to simplify that. So we take out the square root of -1, which is I. That's the point of it. Okay. just substitutes for the square root of -1. We're just pulling it out. Yeah, it's just a fancy way to write the square root of -1 because otherwise you can't solve it. Okay, so when I look at this next one, the square root of -64, and notice this has a plus or a minus in front of it. So I'm going to write this as plus or minus the square root of -1 times the square root of 64. Okay, so I'm going to put my plus or minus out there first. So I have plus or minus. What is the square root of -1? It's cursive I. And what is the square root of 64? 8. So this means that your answer is either positive 8i or it is negative 8i. It's either positive 8i or negative 8i. Does that make sense? Okay, let's look at the next one. So how can I break up the square root of -49 as a product? What two things am I multiplying together? -1, the square root of -1, and the square root of 49. Okay, so the square root of -1 is I. The square root of 49 is 7. Do you guys all notice that there's a negative out in front of that radical? What's that telling you? Yeah, it's going to make your answer negative. So our final answer is -7i. -7i. Okay, on our next example, so is there a perfect square that divides 7? There's not, but it's got a negative in there. So what do we have to pull out of the square root of -7? We're going to pull out an I. So I'm going to rewrite this as the square root of -1, square root of 7, and I'm going to put in 2 in front of it. But we know that the square root of -1 is I. So I have 2i times the square root of 7. So I'm waiting for someone to ask me and nobody has. We've done 4 examples like this. Do you think that we have to show like the times the square root of -1 every time? Well, because I want you guys to understand that when I'm writing it as a product, when I pull an I out, I'm really multiplying by the square root of -1. I want you to see that I'm writing it as a product. But are you okay if we just don't keep writing that over and over again? Okay, so let's just look at what I'm trying to say. So let's see. I know that this is going to stay negative. This square root of -13 means that I can pull an I out. Yep, so I, and then times the square root of 13. So all I did was didn't write it as a product. I didn't write it as the square root of -1 times the square root of 13. I want you to know that like when you see a negative under the radical, just pull an I out, okay? All right, so this next one, I am going to break it up. I'm going to still pull my I out, but I have to break up the square root of 20, and I'm going to break that up as the square root of 4 times the square root of 5. So what is the square root of 4? So I can write my answer as plus or minus 2i square root of 5, or I can break it up and say that my answer is 2i root 5, comma, negative 2i root 5. I'm going to use whichever way you like best. All 3 of those are correct. Like all of, you can either write it like this, or you can do this. Whatever works best for your brain. But notice at the top, when we were looking at our graphs, it says if you have an imaginary solution, right? If you have an imaginary solution, it means like if your graph doesn't cross the x-axis, you're going to have 2 complex solutions. You have to notice that when you have a plus or minus inside, that means that you have 2 complex solutions. And that's unique because complex solutions happen in pairs. Complex solutions happen in pairs. So when you guys get into math 3 and you start doing like cubic and quartic and quintic functions, remember that if you have one imaginary root, you have 2. You have the plus and the minus of it. Okay. All right. What about this last one? How can I break this up? How do you want to break up the square root of -63? Yeah. So I'm going to write 4 plus or minus I times the square root of 9 times the square root of 7. And what is the square root of 9? So I'm going to really write this as 4 plus or minus 3i times the square root of 7. 4 plus or minus 3i times the square root of 7. How do we feel about that? Okay. It is easier than it looks. It looks a little crazy, but it's really not. Okay. Let's flip over to page 2. Let's flip over to page 2. So another big idea is the whole idea of I squared. So let's see. I is the square root of negative 1. And if I square that, that's the square root of negative 1 times the square root of negative 1. But I know that if I take any number underneath a radical and multiply it by that exact same term underneath the radical, it just becomes that number. The radicals disappear, right? So I squared is negative 1. Does that make sense? Okay. So that's our other like really big idea, right? So let's take a look at that. So, when I break this up, I really have I times the square root of 2 times I times the square root of 3. If I simplify that, let's see, I times I is I squared, and 2 times 3 is 6. So I squared times the square root of 6. But what is I squared? So it really is negative square root 6. Okay. Are we thinking about it? Okay. I'm going to write this next one a little bit differently so you can see really what's happening. So I have a negative I times the square root of 3. Do you guys see how my I is negative? Do you see why it's negative? There's always going to be a I in front of the radical if there was a negative underneath it. Yes, sir. Always. Okay. And then I'm going to rewrite this square root of negative 6 as I times the square root of 3 times the square root of 2. Why am I doing that? Well, what is the square root of 3 times the square root of 2? It's the square root of 6. But I know that if I have the same thing outside or the same thing inside, the same exact term inside the radical, what happens to the radical? What is the square root of 3 times the square root of 3?
It makes it so that it's like no longer
radical disappears. It's just 3. It's just 3. So I times I is I squared. So I have negative times I squared. And the square root of 3 times the square root of 3, I heard some of you say is the square root of 9, but it's also just 3 times the square root of 2. But what is I squared? What's the value of I squared? Negative 1. So I really have negative times negative 1 times 3 squared. Sorry, times 3 squared. 3 times the square root of 2. But what is negative 1 times negative 1 or negative times negative 1? Positive. So this is really your final answer is just 3 root 2. I could have multiplied those together and got 18 and we would have broken it up as a square root of 9 square root of 2, but I want you to see what's really happening. Okay, let's look at the next one. So 2 times the square root of negative 5. What's that going to look like? How can I simplify this? Two I times the square root of 5. That's perfect, Parker. Okay. What about this next one? Negative 3 times the square root of negative 10. What's that going to look like, Rose? Square root of 10. Okay. So I have negative 3 times 2. What is negative 3 times 2? Negative 6. I also have I times I. What is I times I? Okay. And what is 5? The square root of 5 times the square root of 10. It's the square root of 50. Okay. So we have to figure out what our I squared is. We have to simplify that, and we have to break up our square root of 50. So what does I squared equal? So I really have -6 times, whoops, I started writing a 6 again. I really have -6 times -1. And the square root of 50 is the same thing as the square root of 25 times the square root of 2. Okay, so what's -6 times -1? A negative times a negative is a positive. And what's the square root of 25? So final answer, 6 times 5 is, so this becomes 30 square root 2. It's kind of cool to think about. It's kind of cool to think about what's happening, right? Nathan, did you shake your head no, like, no, it's not cool, I want to vomit? Maybe? No? Okay, it looked like you shook your head no, like, no, it's not cool. Okay, talk to me about this example. What is this really saying? 3I squared is really saying what? Yeah, this is really just saying 3 times -1. And what is 3 times -1? Yeah, it's just -3. Okay. What is this next one saying? Well, it's saying negative times -1, which does equal a +1. Yes. Okay, so do you see that there's a negative outside of this? Okay, what is I squared? Does that make sense? Okay, perfect. So I know I squared is -1, but I have a negative out in front of it. So I have a negative times -1, which gives me my +1 for that next example. Watch out for stuff like this. I don't know why, but sometimes you guys do voodoo math. What is this actually saying? It's saying 3I times 3I, right? That's what that's really saying. What is 3 times 3? And what's I times I? It's I squared. But what is the value of I squared? It is 9 times -1, which equals -9. I would not skip the step of taking I times I and writing down I squared. Okay, I wouldn't skip that. I know in your brain you know that it's -1, but I would still write it down because these are only going to get harder and you don't want to just botch it. Okay, next one. Well, it's going to be I times the square root of 7 squared, which equals I times the square root of 7 times I times the square root of 7. But the square root of 7 times the square root of 7 is? Well, what is the square root of 49? Yeah. Remember that the square root of a number times itself under the radical, like the square root of 7 times the square root of 7 is just 7. Don't get, okay? And then times I times I is I squared. But what is I squared? So this just becomes 7 times -1, which is -7, which means that we really could have just said, well, the square root of -7 times the square root of -7. What happens when you multiply the same radical term times the same radical term? What do you get? The radicals kind of dissolve. -7. So it doesn't matter whether you look at the orange or the green. The green is kind of like the explanation of why that works. Okay. What are we talking about? This next one. Same thing. So what's my final answer going to be? -16. Whoever said -4, this is -16 times the square root of -16, which is 4I times 4I. But 4 times 4 is 16. I times I is I squared, which is -16. Okay. Who was it who said -4? Okay. Do you see why you were like trying to square it and not think about what was really happening? Okay. How do we feel about those? Okay. I think that we have some examples like this. It says complex number. Do you guys have anything else? Am I missing one? Yeah, I to the 22nd. Is it not on my paper? It is. Okay. I to the 22nd. So here's how I want you to think about these. Take the power of I and divide it by 4 and figure out what your remainder is. Well, let's see. 4 goes into 22 5 times with 20. So that gives me a remainder of 2. A remainder of 2. If I were to divide this in my calculator, I would get something 0.5. The 0.5 is all that I care about, right? So remainder 2, this means that this is going to be an I squared term. But what does I squared equal? It equals -1. So I to the 22nd power is -1. Okay, do you guys feel all right with that? Because remember, I drew the circle on the back of that page. It works in a circle, and every time you get to the 4th power, it equals 1. So then it starts off with I, -1, I, 1 again. So that's 4, 8, 12. Any multiple of 4 equals the whole number 1. But it's the increments, the 0.25, the 0.5 that change. Yeah. So is 40 divisible by 4? Yes, it is. Okay, well, but let me go back here really fast. You're ahead of me. So powers of I, we already talked about this. So I to the first power is just I, which is essentially just the square root of -1. I squared, well, that's the square root of -1 times the square root of -1, which equals -1. I cubed, well, that's I squared times I to the first, right? Because we can add the exponents. But I squared is -1, and I to the first is just I. So that's why it equals negative, which is just saying -I. So we have I, -1, -I. And then when I think about I to the 4th power, well, that's I squared times I squared. But I know I squared is -1, and -1 times -1 is +1. So these are how your powers of I work in increments of 4, multiples of 4. So if I take I to the 40th and I look at my power, well, 40 divided by 4 gives me a remainder of 0, which means that it's going to be 1. Remainder of 0 is 1. Let me write this here. This is a remainder of 1. This is a remainder of 2. This is a remainder of 3. And this is a remainder of 0. And if you think about decimals, this is remainder of 1 is a decimal 0.25. Remainder of 2 is a decimal 0.50. Didn't I do this with you, Josue, on the back of your paper? Yeah. And that made sense. Did that make more sense to you than trying to? Yeah. And then remainder 3 is the same thing as 0.75. And that's what I asked you guys to write on your paper anyway. I just think it makes more sense. Always divide by 4. So 35 divided by 4. Well, that gives me a 0.75 when I put it in my calculator. I don't care about what the first part of the number is. I only care about the last of it, right? So 0.75, well, that's the same thing as I cubed, which equals -I. Okay, what about I to the 17th? When I take that and put it in my calculator, what remainder do I get? What is 17 divided by 4? Yeah, remainder 1 or 0.25. Notice that the remainder is the power of I. So that's just I. I to the first power or I. Remainder 1 is the same thing as I to the first. Remainder 2, 0.5 is the same thing as I squared. Remainder 3, 0.75 is I cubed. Next one. So let's see. We have to take 5 times 2, which is 10, and I times I is, so this equals -10. Yep. -3 times -7 is positive 21. I times I is I squared, but I squared is -1. So this final answer is -21. Remember, you have to do the exponent before you do multiply. So this is really 4i times negative 2i times negative 2i. So 4 times negative 2 times negative 2 is, well, 4 times negative 2 is negative 8 times negative 2 more is a positive 16. I times I is I cubed. And I cubed is negative I. We even have that right here. I cubed equals negative I. So this actually equals negative 16i. Negative 16i. Okay, we're almost done. Almost done. We've got 4 more examples. 4 more examples. Really, there's 8, but we'll do 4 of them. Okay, so complex numbers, A plus BI. So this is the real part. Remember I said you always want the real part to come first? And this is the imaginary part. Because it's got an I attached to it, right? So when you have a number that has any kind of imaginary portion to it, it's called a complex number, okay? A and B are real numbers. A and B are both real numbers. I'm going to write they are both, and I'm going to use that abbreviation for real numbers. A and B are both real numbers, but B is being multiplied by the imaginary unit, right? So I is the imaginary part. I is the imaginary part. So just like combining like terms, just like when you guys learned how to combine like terms, you can't add a real number. You can't combine a real number with an imaginary number and vice versa, right? So when I think about this, I can take, they're joined by a plus sign. I can take 8 and add it to 3 because those are both real terms. What is 8 plus 3? 11. And then I can add my 2 imaginary, 2i plus negative I, 2i minus 2, this is just like saying negative 1. So what's 2 minus 1? It's just 1. So so it's 11 plus I, 1i, or just 11 plus I. 11 plus I. I'll rewrite this next one so you guys can see it. I'll spread it out. Okay, so let's combine our like pieces. So I have 1 plus 4. Sorry, not true. 1 plus 7, yeah. And then I have 4i minus 9i. So this becomes 8. And what is 4 minus 9? Negative 5i. That's your final answer. Negative 5i. What happens when you have a negative in front of your parenthesis? What do you have to do with it? You have to distribute that negative. So this is actually going to get distributed through. So I really have 3 minus I minus 10. And a negative times a negative is a plus. So I can add my real parts together. 3 minus 10 is negative 7. A positive I and a negative I give you what? Nothing. They cancel each other out. Your final answer is negative 7. They cancel out. I have another distribute, right? So I have negative 6 plus 7i minus 3 minus 2i. So negative 6 and negative 3 give me negative 9. And positive 7i and negative 2i give me, yes, positive 5i. Positive 5i. Okay, we're going to do the next two, like the next two on the right side. We're going to do these last two on the right side. So here you have a term that's imaginary and it's getting multiplied through. So negative 4 times negative 2 is what? This is no different than taking negative 4x times negative 2, right? Becomes 8i. Whoops, 8i. And negative 4i times negative 3i, well, negative times a negative is a positive. 4 times 3 is 12, and I times I is I squared. Yes. So what does 12I squared become? Yeah, this becomes 12 times negative 1, which means I have 8I minus 12. 8I minus 12. I want your real number to come first, really. So I really would like you to write it as 12 plus negative 12 plus 8I. That's like the best way to write it. You want a real portion to come first. That last one is foiling, and I know that you guys don't like to foil or double distribute, but we're gonna anyway. We're drawing some arrows. 5 times 6 is 30. 5 times negative 2I is I. Positive 4 times 6 is what? What's 4 times 6? And the I goes along for the right. It's just like 4x or 2x, right? So positive 24I. Positive 4 times negative 2 is negative 8. I times I is I squared. So this, you have to combine like terms. So this 30 is a constant, can't be combined with anything. What about this negative 10 and this positive 24? 10 plus 24 is just 14, right? Negative 10 and positive 24. That's right. Plus, God bless you, 14I. And what happens to negative 8 times I squared? Well, this is negative 8 times negative 1, which is, okay, what happens here?
38.
So, yeah, there's no I. We got rid of the I. It's 38 plus 14I. 38 plus 14I. Okay. So your homework is on page 4 of your packet. Your homework is page 4 of your packet. Okay. Yes, come and write yourself a pass. I'm going to pass out everybody's tests. Yes. Okay. So if you're finished up your test, I want you guys to put all your stuff away. All your stuff away, and
Can we use our like review sheet?
if I okayed you for that review sheet,
You haven't checked mine yet.
yeah, I haven't checked yours yet because you weren't here.
What time is it? What time is it, Zach?
It's like 1:58. 1:58. 1:58. You told me that you wanted to look at it again. Oh, you didn't do any reviewing over the weekend? Mom has to send that at 1. So still use the best most review. I'm still in there. Teacher has to attach. Okay. All right. Zach, you have +2 written on your test because you won points during your review activity.
Who's this?
You can use that. Shade down. I'm gonna get you started on it. So I'm gonna put 3, 4. You're actually looking at 159. So the read aloud is actually on Friday's page, just so you know. Where's your blue review sheet?
Probably in my mind.
Yeah, grab it.
And this one, do I need that?
Yeah, I'll give you one in a second.
It says I'm an absence for but I let you.
Oh, from me?
Yeah. So
Yeah, I'll fix that. No. Shh. I'll come back to you. Kylie, here you go, hon. So, Kylie, do you have your blue review sheet completed? Okay. You use decimal scrapping. David's not here. Naomi's not here. Colt. Oh, meet me halfway. Aaron. Edgar. Kayla. Will. I'll look at it all, Will. Right. Parker. Carter. Guys, if you have a test, you gotta be quiet. Like, that's just it. Don't make me ask for dinner. I'll just come and pull your test. Give you the grade that you have. Like, I'll grade it right now. So, Will, you're sure you're done? Find it? Okay, so I'm gonna put all this. Yes, I said that you could. I just said you have to write your own pass, right? When Parker gets back. Yep.
Can I go last room?
For what? Or you should have been. I'll email Jan Schrum. Are you sure it was from the 16th, the day that you guys did your ACT? Because I can't see your attendance from another class.